So we're going to start off with an example. If you write big like me, you're going to want to write a little bit smaller. So your sheet says factor using the greatest common factor. Right up underneath that to the left, you're going to write 6ab minus 8a squared. Okay? So right up under your first notes, good. Just like that, David, good. You're going to write what's in the red there. These two terms, 6ab minus 8a squared. From here, it says factor using the greatest common factor. So we're going to have to find the greatest common factor of these two terms. Now, when I say terms, all that means is the numbers and variables that I have up here. I know I have two because I have one operation sign, 1, 2. Okay? So factor using the greatest common factor. So I know I'm going to start factoring by using a factor tree. So what times what equals 6?
3 and 2.
And those are prime, so I'm going to circle them. And then I'm going to find the factor of 8.
Wait, where do we write these?
You write that in that big old blank.
Yeah, that big old blank spot. And you're going to kind of write a little bit small.
Wow.
So I'm going to then drop down. I'm going to put my 6 and my 8. If you notice, I'm putting them far over to the side of my paper so I have plenty of space on my right side to draw my area model. What are my prime numbers for 6?
2.
And then what about for 8?
2.
Okay.
And your greatest common factor is 2.
Okay, so from here I circle what they share, which is a 2. So the greatest common factor is 2. Now, I want to slow down because I don't want to leave anybody in the dust here. Now I need to look at the variables. So I have an a and an a squared. Which one do I pick? A and a. Because basically the a by itself is a to the first power. So we're going to pick the one with the smallest exponent, so a. Do they both share a b? No. Since they both don't share a b, they don't have that in common. So my greatest common factor for these two terms is 2a. The next thing I'm going to have to do then is draw my area model. How many rectangles am I going to draw for my area model? 2. Because I have 2 terms, that means my area model is going to have 2 boxes. Is that big enough? No, that's not big enough at all. There we go. Because I have 2 terms, that means I'm going to have 2 rectangles.
Man, why are we drawing this out?
Because we're using area models. This whole triad, we're using area models to help us factor. Okay, so what can I fill out on this area model then? What information do I know about this area model? Well, I have these 2 terms up here, these 2 numbers up here. What do those 2 numbers represent? Is that what you're going to say?
I was going to say that.
It's not going to be the height and the width. Why not? What's not around them?
Oh, parentheses.
The parentheses. Because there's no parentheses around them, these are going to be my areas of each rectangle. So what's my first area going to represent?
6, 8,
Okay, and then what's my second area going to be?
8.
Okay, now remember, we put our areas on the bottom. What other information do I know about this? What is the greatest common factor? What's that 2a represent? The height. Good. So if that represents the height, I'm going to put my height on the outside here. So all I need to find now is the width. So the height times something, and the height times something to get my area. So that something is going to be the width that we're finding out.
Is it 3?
Okay? So we're thinking to ourselves, 2 times what gets us to 6? Would you say, Kaylon? 3? Okay, give me a second here. I have A up here, and I have A for my total area. So do I need any more? No. Okay, my height times my width got me the total area of 6AB. What am I missing? A B. So the width is also going to have a B in it. So what's the width of my first rectangle? Now if you notice, I'm showing all my work. I'm showing every single thing. I'm showing my height times my width equals the total area. I'm labeling my height, and then I'm going up and labeling my width. I expect to see all of your work on this area model. Okay? Now I go to find the width of my second rectangle. 2 times what gets me to negative 8? Negative 4. A got me to A squared, so what do I need? 1A, right? So the width of this rectangle is? Okay, so now I have area equals what? What's area equal? Height times width. So what's my height? So I'm going to come up to the right, put equal. What's my height? How do I show that my height's being multiplied by my width? Parenthesis, then what?
Parentheses.
There you go.
Done.
That's it. Okay? It's a lot. I know.
Do the rest.
Okay, you guys want me to show you something?
No.
Too bad, I'm going to show you anyway. Okay, so right here, look how this is a list. This is like an easy way to check your work. See how this is a 6 and a 6? What number did I not use? What number wasn't in common?
3.
What's the width?
3B.
Well, we had to add the variable, but the number's 3, right?
Yep.
What numbers didn't I use for the 8? Which is what? 2 times 2 is 4. What do I use here? So, well, you have to pay attention to that. But I always thought that was kind of neat. So your leftover numbers. Oh, don't worry. You can still be lost because we're going to do another example.
No, Miss Lincoln, that's how I had did it. I did when you had said what is 2, what equals 6. I looked up what is 6 at by the AB. No, above that. Right there, yeah, and I see the 3.
You use that. Oh, so you use that leftover one.
Yeah, and then I did the other one for the 4.
All right, we all have this. What do you guys think? Thumbs up if you got it. Thumbs in the middle if you're like, okay. Thumbs down if this is like French to you, like a foreign language. All right, it's about what I expected. Honestly, this is hard. Okay, let's do a couple little notes here. Let's fill in the blanks. Okay, determine the what? What's the first thing that we did? What did we find first? Say it again. We found the greatest common factor of all the terms in that expression. So find the GCF, greatest common factor. Draw an appropriate area model with one blank for each term in the expression. So we had 2 terms in our first expression, right? So how many rectangles did I draw? So we're going to, with 1 rectangle for each term. So you draw 1 rectangle for each term. Then you put the greatest common factor on the blank of the rectangles. That greatest common factor represents the what? I think I heard it. No, not from over there. When we found the greatest common factor of the first terms, what was the greatest common factor of my 6 and my 8? That was 2a, right? What did that greatest common factor become? The height. So put the greatest common factor on the blank of the rectangles. The outside or as the height or the side. I'm going to put the height, so maybe put in parentheses left side. Because you don't want to just put the side because, well, I guess side and top are different, but I like to be pretty specific. Once you do that, what's step 4? Complete the model. Then using the model, write your answer. Once you have that down, go ahead and flip your note sheet over. We have 2 more examples.
We got a worksheet to take home?
Yeah, but if you notice on the board, how many worksheets am I giving you this week? 1. Okay. And am I giving you any other worksheets this week?
Yep, fine.
That's not a worksheet. That's technology.
I don't like it.
Okay.
Share with just these kids.
Example number 2. How many of you guys actually did some con this weekend over Easter?
Nobody.
I'm not gonna lie. I had a student text me about grades, and I'm like, I will get back to you on Tuesday. I'm taking a break too. Okay, so factor using the greatest common factor. So you're gonna write what's in the blue right up underneath your directions there. So you're gonna write those 3 terms right under factoring using the greatest common factor. So 45 c to the 4th d squared minus 27 c cubed d cubed plus 54 c squared and d to the 6th. If you write big, like me, you want to try to write a little bit smaller so you can fit all this in. I didn't give you guys a whole lot of space here. What's the very first thing that I need to do with these 3 terms? Yeah, so I need to find the greatest common factor. So what are my factors for 45?
9 and 5.
Okay, I need to make my pen smaller. Give me just a sec. Okay, and then for 9? Does that look blurry? Okay. For 27?
9 and 3.
9 and 3.
Okay, and we know 9, you already told me was 3 and 3. And then what about for 54?
No, 6 and 7.
54, 6 and 7?
Wait,
Oh,
no.
sweet. Thanks.
Yeah.
No, it's 6 and 9.
No, 6 and 9.
6 and 9. I agree with that one. Okay, and 6 is,
2 and 3.
and then 9 we know is 3 and 3. A lot of 3s here, right?
Yeah.
So I'm going to come over to the side, way over here. Oops, that's not what I want to do. I'm going to write 45, 27, and 54. So what are my prime numbers in order from least to greatest for 45?
3, 3, 5.
2, 3, 1, 5.
And what about for 27?
3, 3.
And for 54?
2, 3, 2. No, 2, 3, 3, 3.
Okay. What's next?
Circle.
Not pairs, what they have in common. So what do all 3 numbers share or have in common?
3,
2.
So they have a,
rows of 3.
so they have a 3. Anything else?
One more row.
another 3, and then another 3.
No, I know more 3.
That's it,
No,
AJ.
Is that it?
Yeah.
That's it. All right, so I'm going to come down here. I'm going to write my greatest common factor. So I can either write out 3 times 3 and write my answer, or I can just take 3 times 3, which equals 9. So I'm just going to do that because we are writing a lot now, right? So now I need to look at my variables because I can't forget about them. Do they all have a c?
Yeah.
Which is the one with the smallest exponent?
C to the 2nd.
So we're going to use c squared, right? So then I come to d. Do they all have a d?
Nope.
What's the smallest?
D to the 2nd.
D to the 2nd. So now that I found the greatest common factor of my 3 terms, what does this 9c squared d squared represent for my area model? The height, okay? When I draw an area model, how many rectangles does it need to have? 3, because I have 3 terms. So I'm going to draw my area model as big as I can. Okay? Draw my lines to make sure that I have 3 rectangles. Okay. So from there, we're going to start filling in the information that we know. So what do I put? Well, I have these 3 terms here. Those three terms here represent the area. So what's my first area?
45.
And then all the variables, right? 45. C4, d to the second. What's the area of my second rectangle? Wrong.
What?
You heard me.
-27.
Negative 27.
Oh.
Because would you rather have $27 or have negative 27? You'd rather have 27, right? 27 and negative 27 are two very different numbers. Would you rather have negative $1,000 or $1,000? Okay. And the area of my last rectangle.
54.
Okay. What other information do I know? What does the greatest common factor tell us? It tells us the height. So according to our notes, we put our greatest common factor as the height or on the left side of our area model. So my height is 9c squared d squared. So I'm going to go ahead and write the height because the height times width equals the total area. So I'm going to go ahead and write my height on the inside too.
It's 5.
So we have what? 9c squared d squared. And so I'm trying to find the what again? The width. Okay. So here we go.
Your width for the
9. Well, let's just use this.
5.
What number did I not use?
5.
9 times 5. Does that equal 45? Yep. So now we need to look at our variables. I have c squared here. I have c to the fourth here. How many more c's do I need? 2. So c squared. I have 2 or d squared up here, d squared down here. Do I need any more d's? Do I need
Nope.
any other variables? Nope. So the width of this first rectangle is 5c squared. The 45 would be my area, remember? The width is what we just found. Okay? So then, what number do I have left over for my 27?
3.
Okay? But down here I have a positive times something is going to be a negative. So what does that 3 have to be? Negative 3. So 9 times negative 3 does get me to negative 27. I have c squared, c to the third. So what do I need? I just need one more. If you go from 2 to 3, think 2 plus 1 equals 3, one more. I have d squared. I end with d to the third. How many more d's do I need? So what's the width of the second rectangle?
Negative 3 CD.
Okay. And my last one. What number do I have left over? 6, because I had a 2 times a 3, which will be 6. Okay, c squared, c squared. Do I need any more c's? D squared, d6. Do I need any more d's? If I'm going from d2 to 6, I need 4 more. What's the width of the second rectangle?
64.
Okay. I am almost done, or not I, but you guys are almost done with this one. So my area model's filled out. The top I have area equals height times width. What's my height?
9C to the negative
Times, what's my widths?
5C to the negative 3 CD plus 64.
In box. There it is.